Hello everybody. Today we're looking at the behavior of waves. So the other day we covered what waves are and what are the different types of waves. Yesterday we took a look at the different parts of waves and the features of waves, and today we're looking at how waves behavior. So let's get started. Make sure you have your notebook out, and this is our essential question for today. What do an echo, a shadow, and your reflection have in common? Well, I'm sure we've experienced all three of these things. So our goal today is going to be to answer this question after we get through the notes. So let's get busy. The behavior of waves. This is the title of our notes. This is where it's going to be saved in when we turn it in eBackpack. We're starting off with the law of reflection. This law states that as a wave comes into a surface, it has an angle of incidence, and that angle is going to be equal to the angle of reflection as it bounces off. And we can see this in the picture here like this. This is a light ray, a drawing of a light ray. The light ray is coming into a mirror, and then it bounces off for reflection. According to the law of reflection, this angle of incidence is from here to the normal. This is a perpendicular line drawn from the mirror. This angle of incidence is equal to the angle of reflection. So we've got I equals to R. That's the law of reflection. All right, so what is reflection? By definition, a reflection occurs when a wave strikes an object and bounces off of it. And we can deduce from that that all types of waves can be reflected. For example, sound can be reflected. Water can be reflected. I'm sure we've seen that anytime we've been in a swimming pool. And light can be reflected. We see that every time we look at ourselves in the mirror. Next up, we've got some more behavior of waves. We have refraction, which is the bending of a wave caused by a change in its speed as it moves from one medium to another. And we have diffraction, which is the bending of a wave whenever an object causes the wave to change direction and bend toward it. And we can see here at the bottom that both refraction and diffraction cause waves to bend, but, however, refraction occurs when waves pass through an object or a medium, and diffraction occurs when waves pass around an object. And we can see this in our pictures right here. This person sitting in a swimming pool right here, looks like his head is sitting clear over to the side of him, but that's not really the case. What's happening here is that the light waves, as the light waves go from the air down to the water, they bend, and it looks like they're bending this way. That's why it looks like his body is clear over beside his head. Okay? So this is an example of refraction. Now down here we have an example of diffraction. Notice how we've got this barrier of all these rocks and things. It's a natural barrier. And the ocean waves are coming in. As the waves hit the barrier, they go through this tiny opening here, and then they bend around it. See how they're making like this big circular pattern? That's a form of diffraction. And when we look at our lab today, we're really going to be spending a lot of time on diffraction and looking at how the light bends from one medium to another, and also as we have a boundary or some other object in the way. All right, our next thing we have today is interference. Interference occurs when two or more waves overlap and combine to form a new wave. So interference is just like it's an interaction between waves. There are two types of interference that we're concerned about. We've got destructive and constructive. So without even looking at this diagram, you already know what these are. Destructive means it's destroying, right? It's tearing it down. Constructive means it's building it up. And that's exactly the way it is. So for destructive waves, say we've got these two waves. See how they're kind of out of phase a little bit. We've got the peak or a crest and a trough added to the opposite side of the wave here. And when we add these two waves together, they overlap, and it ends up destroying both of those waves. So if you've ever experienced trying to get your radio station in and it doesn't work, like the only thing you're hearing is static and stuff, that's a result of destructive interference, because there are multiple wavelengths coming into the receiving part of your radio, and they're interfering with each other, and you're only just getting the result, which is a flat line or static or something like that. Another example of destructive interference is, you know, a lot of times our Wi-Fi at school doesn't work. That's because oftentimes there's something interfering with that. Okay. Another example here, we've got constructive interference. Now, constructive interference is whenever you take two waves, you add them together, and the result of those waves is bigger. Okay. An example of this would be like when we have people screaming at a football game or a basketball game or something like that. All of these people are producing sound waves, and as their sound waves come in phase with each other and they add together, a lot of people screaming at the same time with the same amplitude can add together and make a much, much bigger sound. So it can be a really constructive interference. So we have two types of interference. One results in destroying the waves, destructive. The other one results in adding those waves together to make it bigger amplitude. That is constructive. All right, so we went through all these different behaviors of waves. Let's go back to our essential question. Can we answer it now? What do an echo, a shadow, and a reflection have in common? All right, I want you to sit and discuss with your partner or with the person you're going to work with on the lab today, and come up with an answer. Make sure you write that answer down in your notebook next to this question, and if you're not sure, make sure you ask Mrs. Parson or Mrs. Witt, and we'll let you know. All right, let's get ready for our lab.